You know, it always seems like we hear about just the insane cost of space travel.
Yeah.
Like getting just a pound of anything up into orbit costs a fortune.
Right.
Makes you really think about the future with missions like Artemis,
Mhm.
aiming to establish a more permanent presence on the moon.
Yeah.
How do we make that sustainable?
Well, that's a question NASA's tackling head on, actually,
Oh, really?
with a fascinating approach.
Wow.
They're looking beyond just that initial trip,
Yeah.
focusing on long-term solutions, particularly for waste management.
Okay. That piques my curiosity right away.
Yeah.
What exactly are they doing?
Well, they've launched something called the Lunar Recycle Challenge.
Okay.
It's a competition offering $3 million in prize money
$3 million.
to anyone who can develop innovative solutions for dealing with waste on the moon.
Wow. They're serious about this.
They are.
But why the focus on waste? Is it
Correct.
really that big of a deal in space?
It really is.
Okay.
It all comes down to resources. Transporting materials to the moon costs roughly $100,000 per pound.
Wow.
So the more we can recycle and reuse what we already have up there,
Right.
the less reliant we are on these costly and complex supply chains from Earth.
That makes a lot of sense.
Yeah.
So this Lunar Recycle Challenge,
Mm.
is it about like figuring out how to compost food scraps in zero gravity or something?
That's a good question.
Yeah.
It's actually focused on a very specific category of waste.
Okay.
They're calling it non-gaseous,
Okay.
non-biological,
Uh-huh.
and non-metabolic solid waste.
Well, what does that mean?
Basically, think about all the stuff that accumulates on a mission.
Okay.
Packaging from food and equipment,
Yeah.
worn-out spacesuit materials, even structural elements
Wow.
that might need replacing,
Okay.
all that stuff.
So it's more about the durable materials, the
Yeah.
stuff that's hard to break down even here on Earth.
Precisely.
Okay.
And they're looking for solutions that can transform this waste into usable products
Interesting.
directly on the moon. Right. That way it can support future missions and reduce the need to ship everything from Earth.
This challenge sounds like it could generate some really creative solutions.
Yeah, I think so.
What are some of the approaches NASA's looking for?
So the Lunar Recycle Challenge is split into 2 tracks.
Okay.
The first is the digital twin track.
Digital twin.
Yeah, and it's all about creating virtual simulations of recycling solutions,
Okay.
but using real-world data from lunar missions.
So it's like a high-tech, space-themed design competition,
Yeah,
but in the digital world.
exactly.
Cool.
It allows teams to test and refine their ideas virtually
Makes sense.
before moving on to physical prototypes.
Right.
And then there's the prototype build track,
Okay.
where participants actually design and construct physical models
Oh, wow.
of their recycling inventions.
I like that they're incorporating both virtual and physical approaches.
Yeah.
It seems like it would attract a much wider range of participants.
Yeah, that's a key part of their strategy.
Okay.
NASA wants to tap into the brightest minds across all disciplines,
Right.
whether they're seasoned engineers or just someone with a really groundbreaking idea.
Yeah.
And to help with this, they've partnered with the University of Alabama,
Okay.
led by Dr. Rajiv Dorswamy, to manage this challenge.
It's interesting that they're emphasizing this collaborative approach.
Yeah.
It seems like NASA is really trying to shift the narrative around space exploration, make it more about global ingenuity and sustainability,
Right.
rather than just this race to plant a flag.
I think you hit on a really important point there.
Yeah.
The way NASA is framing this challenge,
Yeah.
it seems to be about so much more than just cleaning up space junk.
Right.
It's about showing a commitment to responsible and sustainable exploration for the long haul.
And what about the potential impact beyond space travel?
Yeah.
Could any of these lunar recycling solutions have applications here on Earth?
That's one of the most exciting aspects of all of this.
Oh, really?
NASA officials have actually stated that the technologies developed for this challenge
Mm-hmm.
could very well have implications for sustainability efforts right here on Earth.
Wow.
Imagine the possibilities.
Yeah.
Innovations for recycling in remote areas.
Right.
Advancements in closed-loop systems for urban waste management.
Yeah.
The potential is pretty vast.
So by tackling the challenges of space waste, we might discover new ways to be more sustainable here at home.
I think so.
That's a pretty compelling thought.
It is.
Okay, so we've established that NASA is getting serious about sustainability in space, and they're putting some serious money behind it with this Luna Recycle Challenge.
Right.
But let's get down to the nitty-gritty.
Right.
What exactly does this waste look like?
Right.
And what are the unique hurdles of dealing with it on the moon?
That's where the real ingenuity comes in.
Okay.
We're not just talking about separating paper from plastic here.
Right.
This is about breaking down complex materials and transforming them into valuable resources under some extremely challenging conditions.
I can imagine.
Yes. Remember we talked about those spacesuits?
Right.
They're incredible feats of engineering
Yeah.
designed to withstand these extreme temperatures and radiation.
Yeah.
But that also means that they're made from incredibly complex materials.
Right. Those multi-layered fabrics,
Yeah,
the specialized coatings. It's not like you can just toss those in a recycling bin.
exactly.
But,
And it's not just spacesuits.
right.
Think about the packaging for all the equipment and supplies
Yeah.
sent to the moon.
Right.
Much of it's designed for single use, and it's made from these durable,
Yeah.
often composite materials
Uh-huh.
that are difficult to break down, even with Earth-based recycling technologies.
So the challenge isn't just figuring out what to do with this waste.
Right.
It's how to do it with the limited resources and technology available on the moon.
Yeah.
What are some of the hurdles that they're facing?
Well, the lunar environment itself presents a whole host of challenges. For one, there's the issue of extreme temperatures.
Okay.
During the day, the surface of the moon can reach over 250 degrees Fahrenheit.
Wow.
At night, it plummets to negative 280 degrees.
That's a wild swing. I
Yeah.
imagine that puts a lot of stress on any equipment you're trying to operate.
Absolutely.
Yeah.
And then there's the radiation.
Right.
Without a substantial atmosphere to protect it,
Yeah.
the moon's surface is bombarded with solar and cosmic radiation
Oh, wow.
that can degrade materials over time and pose risks to human health.
It sounds like designing equipment that can function reliably in that kind of environment
Yeah,
is a monumental task in itself.
it is.
Yeah.
And let's not forget about the dust.
The dust.
Lunar dust
Yeah.
is incredibly fine and abrasive,
Oh, wow.
and it gets into everything,
Really?
clogging machinery, damaging seals, and even causing respiratory problems for astronauts.
I remember reading about how the Apollo astronauts struggled with the dust.
Yeah.
It seemed like it got into everything, even back inside the lunar module.
It's a persistent problem.
Yeah.
So any recycling system designed for the moon needs to be incredibly robust and dust-proof.
Right.
That adds another layer of complexity
Yeah.
to the engineering challenges.
This all sounds incredibly daunting,
It is?
but I'm also curious about the potential.
Yeah.
What are some of the solutions that researchers are exploring?
That's where it gets really exciting.
Okay.
There's some incredibly innovative ideas being explored,
Yeah.
often drawing inspiration from diverse fields
Okay.
like robotics, material science, and even biology.
Give me an example.
Okay.
What's got you particularly intrigued?
One promising area is 3D printing using lunar regolith.
Okay.
Regolith is essentially the loose dust and rock
Yeah.
that covers the moon's surface.
Right.
If we can figure out how to effectively utilize it,
Mm-hmm.
it opens up a whole range of possibilities.
So instead of shipping construction materials to the moon,
Yeah,
we could use what's already there.
exactly.
I've heard about 3D printed habitats,
Mm-hmm.
but what about using it for recycling?
That's where the innovation comes in.
Okay.
Researchers are exploring techniques for using 3D printers
Yeah.
to break down waste materials and reconstitute them into new forms.
Wow.
It's like a high-tech version of those machines that turn plastic bottles into fleece jackets.
But instead of making clothing, we're talking about creating building materials, tools, maybe even replacement parts for equipment.
Exactly.
Okay.
And because it relies on this readily available lunar regolith,
Yeah.
it significantly reduces the need to transport materials from Earth.
Right.
It's a game changer for sustainable construction and manufacturing on the moon.
That's pretty mind-blowing.
Yeah.
What other solutions are out there?
Another area that's gaining traction is biorecycling,
Biorecycling.
specifically using microorganisms to break down organic waste.
So like a supercharged composting system.
Yeah.
But for the moon.
In essence, yes.
Okay.
Certain types of bacteria and fungi are incredibly efficient at breaking down organic matter and converting it into usable products.
I know that some composting systems can even generate methane,
Right.
which can be used as fuel.
Mm-hmm.
Is that something they're looking at for lunar applications?
Absolutely.
Okay.
Generating biofuels on the moon could be a major step towards self-sufficiency.
Yeah.
And beyond fuel, these microorganisms could also be used to create fertilizer
Right.
for growing food in lunar greenhouses.
I never thought I'd be discussing composting and space travel in the same conversation.
Yeah,
But it makes perfect sense.
it does.
It's like nature's own recycling system, adapted for a completely alien environment.
And it highlights a key theme of this challenge,
Okay.
drawing inspiration from both cutting-edge technology and the natural world
Yeah.
to find elegant solutions for sustainable living beyond Earth.
It's fascinating how exploring these new frontiers is pushing us to rethink our relationship with waste and resources,
Yeah,
not just in space, but here on Earth as well.
I think so.
It's amazing to think that solutions inspired by nature could be the key to sustainable living on the moon.
Yeah.
But even with these innovative approaches,
Uh,
I imagine there are still some significant hurdles to overcome.
yeah, definitely.
What are some of the biggest challenges facing this lunar recycle challenge?
I think one of the biggest hurdles is just the complexity of the waste itself.
Okay.
We're not talking about simple materials,
Right.
like aluminum cans or glass
I don't
bottles.
think we deal with here.
These are really high-tech, multi-component materials designed for those extreme conditions.
Right. We talked about those spacesuits, for example.
Exactly.
Breaking those down into their base components and then reprocessing them into something useful.
Yeah.
Sounds like a massive undertaking.
It's a huge material science challenge.
Yeah.
And then there's the issue of developing systems that can actually function reliably
Right.
in that lunar environment.
Right.
We've already touched on the temperature swings, the radiation dust,
Yeah.
but there's also the vacuum to consider.
Oh, right. The vacuum.
Yeah.
Hadn't even thought about that.
Yeah.
How does a vacuum affect the recycling processes?
Well, a lot of the recycling techniques we use here on Earth
Yeah.
rely on processes that involve air or water.
Right. Of course.
In a vacuum, those processes have to be completely re-engineered.
Wow.
It requires a different way of thinking,
Yeah.
designing systems that are self-contained and can operate without relying on those Earth-like conditions.
It sounds like we're going to need some serious technological breakthroughs to make this work.
Yeah, we are.
What are some of the areas where innovation is most needed?
I think robotics is going to play a huge role.
Robotics. Okay.
Yeah, we need robots that can handle these delicate tasks,
Right.
operate autonomously, and withstand that really harsh lunar environment.
Yeah.
Artificial intelligence will also be critical
Mm.
for tasks like sorting and identifying different types of waste, and then optimizing recycling processes in real time.
So it's not just about developing new materials and processes, but also creating a whole new generation of spacefaring robots.
Yeah, I think so.
It sounds like this lunar recycle challenge is really pushing the boundaries of multiple fields simultaneously.
It is. It's bringing together experts from all these diverse fields
Yeah.
to tackle this common challenge.
Right.
And that cross-pollination of ideas is often where the most innovative solutions emerge.
It makes me think about how the space race in the 20th century
Hmm.
spurred so many technological advancements
Yeah.
that ended up benefiting us here on Earth.
Right.
Could this new push for sustainability in space have a similar ripple effect?
I believe it could.
Yeah.
The technologies being developed for the Lunar Recycle Challenge could have applications in areas like resource extraction, closed-loop manufacturing,
All right.
and waste management in extreme environments here on Earth.
Interesting.
It's about pushing the limits of what's possible and then bringing those lessons back down to Earth.
It's a reminder that even though we're talking about space exploration,
Right.
it's ultimately about solving problems that affect all of humanity.
Exactly.
So as we wrap up this deep dive into the Lunar Recycle Challenge, what's one key takeaway you want our listeners to ponder?
I think the future of space exploration is inextricably linked to sustainability.
Okay.
The Lunar Recycle Challenge is a testament to that.
Yeah.
It's about recognizing that resources are finite,
Right.
even in the vastness of space.
Yeah.
And we need to be mindful stewards of those resources if we want to have a long-term presence beyond Earth.
It's a powerful message and one that resonates really deeply,
Yeah.
especially as we face growing concerns about resource scarcity and environmental sustainability here on our own planet.
Right.
Thank you for taking us on this incredible journey into the world of space waste
It was my pleasure.
and the innovative solutions being explored.
Yeah.
It's truly inspiring to see how human ingenuity is tackling these challenges and paving the way for a more sustainable future, both on Earth and beyond.